So problem 20 is, you might recall at the very, very beginning of chapter 4, we did the angle of elevation and depression. Now, if they talk about an angle of elevation, remember you are above the thing looking downward. If you're talking about an angle of elevation, you're below the thing looking upward. So look at how they word the question. So let's read 20. It says the length of the shadow of a tree is 170 feet. So here's our tree. Can't you tell? And it says that the shadow is 170 feet when the angle of elevation of the sun is 17 degrees. So we're going to assume when they say angle of elevation, they're talking about from the ground rising upward. That is 17 degrees. Approximately, what is the height of the tree? So you're just setting up a normal, good old SOHCAHTOA sort of problem. Once you've drawn your triangle, my suggestion is label what the sides are that you know. Are they opposite, adjacent, or hypotenuse? This one is your opposite. This one is your adjacent. This one is your hypotenuse. So if you think about SOHCAHTOA, the one we want is the one that contains opposite and adjacent. So that's the TOA part of it. So that's your tangent. So I know the tangent of 17 is opposite over adjacent. Now once you set that up, the basic rule that I always follow so that I don't screw up the algebra that comes later is whatever is in your denominator on the other side. Whatever is in your denominator, let's cross multiply that over. So we know that the tangent of 17 times 170 is x. Now, see how it says approximates to the nearest hundredths. That tells you, at this point we're going to need a calculator. This isn't something we can do with the unit circle. And so you're just going to do the tangent of 17, make sure your calculator is in degree mode, and then you're going to multiply that times 170. We're going to round it to the nearest hundredth. So that would be 593.97 feet. Okay, so that is number 20. Okay, any questions about that one? Okay, the next one that I had circled was problem 25. I'm going to do C and D on this page, and then I have F and G. So we're going to do C, D, F, and G. So if you're wondering what that symbol is in the problem, that's a beta. Doesn't really matter. It looks like a fancy B. That's a beta. What we're going to remember, what we're trying to accomplish. If you are to verify an identity, you are trying to get the sides to match. Okay, we're trying to get the sides to match. So we're going to hold one side and make the other side match up. Okay. Now, it really doesn't matter which you decide to hold and which you decide to change. It really doesn't. I usually try to find that one that has a little bit more stuff in it to change over to the one that's a little simpler. In this particular case, they're both pretty equal, but what I'm going to do is I'm going to hold this side, just because something occurred to me that I'll be able to switch, and I'm going to try to get this side to match. Okay, so it's kind of like if I said, hey, simplify this, I'm going to tell you the answer is 14 cosine squared beta minus 7. So you know the answer. Remember, this is the answer. So how do we go about doing that? Well, some of the identities that are not on the board, but that you might want to write on your card are the Pythagorean identities. your Pythagorean identities that contain sine and cosine, I know that sine squared plus cosine squared is equal to 1. And so what I'm going to do, if you'll notice, I'm trying to get only cosines to appear in the problem. So I'll be able to take this out and replace it with something containing cosines if I can rearrange this. How would I go about rearranging this? So it said sine squared equals. What could I do mathematically to do a rearrange so it says sine squared equals? Subtract the cosine squared. So if I subtract a cosine squared from both sides, I know that sine squared is equivalent to 1 minus cosine squared. So that's a substitution that's a legal substitution. So I am going to take out the sine that I see here, and I'm going to replace it with a 1 minus cosine squared. Because the one side only has cosines, let's my side also to only have cosines. Now, this -7, you'll notice that I put that in parentheses so that I remind myself, hey, I need to distribute that. So at this time, the next thing you would do algebraically is let's just do distribution. So let's do that. So we're going to get 7 cosine squared minus 7 plus 7 cosine squared. And if you look back at the original problem, I found the -7 I was looking for. And 7 cosines plus 7 more is going to be the 14. So I found it. The answer is 14 cosine squared beta minus 7. Now, I know on the test there are a few actually that are not multiple choice that are like this. And you'll have to just write that down, take a picture of it, submit it, and then get some points for that. Okay. So that is, I know some identities on the test. Any questions about 25C before I move on? Okay, let's try 25D. So let me write that down. That says the tangent squared of alpha over the sine is the secant of alpha tangent of alpha. Now it is your decision which side to hold. It really is totally your decision. But I like fractions because it gives me something to do. It gives me something to mess with. So I'm going to hold this and try to get that fractional side to switch and become a secant and a tangent. Now you see how we need a tangent in the problem. So let's rewrite this left side. Let's write it as tangent times tangent over sine. Now the reason I do that is because I'm allowed to. I can split it. Because I need a tangent all by itself, why not pull out one of the tangents and write it alone? Leave it alone. It's there. Let's leave it there. Let's see if this can somehow become a secant. Does anybody remember what secant is the reciprocal of? Secant is the flip of the sine, cosine, tangent, secant, cosecant, or cotangent. Secant is the flip of the cosine. That's 1 over the cosine. It's really bad you don't know that. So this right here, that secant, you got to keep in mind, well, you know, I need it to be a 1 over a cosine. So you got to think of that. And that's why make sure on your card you have written your Pythagoreans, your reciprocals, and your quotients. So let's rewrite this. So tangent, and I'm talking about this tangent, is sine over cosine. Sine is just sine. So we'll put it over 1 so we have 2 pieces. Now the reason I want to do that, do you remember when we've done a few different times that big C over little c? Because things can cancel sometimes. Do you see where the sign is located? The big C has a sign in it. The little c has a sign in it. That tells me the sign's going to go away. And so I get tangent of x times 1 over the cosine of x, because the signs actually end up canceling out. And so I end up getting 1 over cosine. What did we say 1 over cosine was? The secant. And so we've turned it into a secant. Does the order matter in multiplication or addition? No. So since it's a multiplication, I don't have to flip it. You don't have to. You can if you want to. So there is 25D. So it's all about algebra. Not knowing those facts isn't helpful, so you either memorize them or you make sure you have them available, okay? The next one we're going to do is 25 F and G. 25 F and G. So let's start with 25F. It is really pretty obvious in this one that the fractions have a lot more stuff there than 2 secant. Now remember, 2 secant is the same as 2 over the cosine. That's probably what's going to appear as our last step. Okay? So let's hold this one. That's going to be considered our answer that we need to get the others to match. Now, when you see 2 fractions being added or subtracted, the thing you want to do is try to add them together. You do that by getting common denominators. Okay. So how do we do that? Put everything in parentheses that is more than one piece. We're going to multiply the right denominator over here on the left side. Whatever you do to the bottom, you also do to the top. We're going to multiply the left denominator over here. So we're going to multiply here by cosine on top and bottom. Now, for our purposes, most of the time, on the bottom, we are not going to actually do that multiplication because it usually just complicates things. What did I tell you 2 secant of x was? Wasn't it 2 over the cosine? Don't we want a little cosine left in there? So it's not a bad idea that the cosine's sitting there because it's waiting. Okay. But this stuff we should actually physically multiply. Now, these 2 pieces are foiling. You got to actually foil them and multiply them through. So we got to actually do that. So let's do that. Okay. Sorry, I hit the wrong thing. Okay. So we're going to get 1 plus the sine of x. Now that's when I distributed the 1. Now I need to distribute the sine. We get sine of x plus sine squared of x. And then that's done. And then this one here is a cosine squared of x. Now there is a trick. This trick happens, I've seen it lots of times. A sine squared plus cosine squared will appear in the problem. What is sine squared plus cosine squared? 1. So take that out, put a 1 there because it's equal to 1. Okay, let's do that. So we get 1 plus the sine plus 1. Now, we have some like terms that we can put together. 1 plus 1 is 2. A sine of x plus the sine of x is 2 sine of x's. Now, look back at our original answer. We need a 2 to show up. Didn't a 2 show up? Now, how can we get the 2 to kind of be there? Well, factor it out. So if we factor, what do you notice can cancel out? The 1 plus sine of x. We don't want it there anyway, do we? Remember, we wanted these things to be there because a 2 over a cosine is the same as a 2 secant. Remember, keep looking back at what's my answer, what am I trying to get, what is 2 secant? Secant is 1 over the cosine, so that's 2 over the cosine. You know, keep going back to what am I trying to accomplish. You're trying to get the sides to match. Pick a side, manipulate it. So there's 25F. Now let me write down 25G. I'll write it over here. Okay. So here is 25G. So, even though I should only ever touch and manipulate one side, I am going to just give myself a little hint. And I'm going to write down what is this really, what is that? Cosecant, cotangent, what the heck does that mean? Well, that's really negative 18. Cosecant is the flip of the sine. Cotangent is cosine over sine. So right before this answer comes up, this answer should come up as like your very, very almost last step. Okay? So sometimes when it's a weird, complicated sort of mess of junk, I will write this to the side as a reminder, what is that junk equal to? So it's just a little reminder, hey, that's what I'm looking for. So we really want some sines on the bottom, a cosine on the top, and a negative 18 to show up in the problem. Okay. But the technique we used on the last problem is exactly what we're going to do again. So let's do it. I'm going to hold this side. Remember, this is what I'm shooting for. I'm going to get common denominator. So I'm going to put any pieces in more than one term in parentheses. I'm going to multiply the left denominator on the right side, the right denominator on the left side. Okay, so what's going to happen? Well, this side's going to get a cosine of beta minus 1. Was it a cosine? Did I write that down? Yeah. Okay. And then this side's going to get a cosine of beta plus 1. Okay. Now what do we have to do? Well, we have to distribute. So the bottom, now the last bottoms, one was a sine and one had like, one was a quantity, one was a cosine. It didn't help us to multiply them. Usually only denominators that are conjugates are nice to actually physically multiply. See how these are perfect little conjugates, cosine minus 1, cosine plus 1. Let's put them together. That's really cosine squared minus 1. So if they're conjugates, physically actually multiply. Now on top, we just have to distribute a 9 here and distribute a 9 here. So we're going to get 9 cosine of beta minus 9 plus 9 cosine of beta plus 9. So here the 9's cancel out. The cosines come together. And please put on the bottom, that's a cosine squared beta minus 1. Okay. So we get 18 cosine beta over cosine squared beta minus 1. Now, let's look at what I had written to the side here. Okay, so we found an 18, but not a negative. So we're close. We found a cosine on the top. Close. How could we turn the bottom into sines? If we have a cosine squared minus 1, how could we turn that into sines? How do we know the sine and the cosine are related? What do you think? How is a sine and a cosine related? Kayla, you told me a second ago. What was it? You told me in the last problem. What do we know about a sine and a cosine? Do you remember? The squares added together equal 1. Sine squared plus cosine squared equals 1. So that fact, it shows up so much. So that's really an important fact. So let's write down up here, sine squared plus cosine squared equals 1. Now, do you see what we're trying to match? We're trying to match a cosine squared minus 1. So if we move this cosine over, do we get that? Do we get cosine squared minus 1? No. It's close, right? Do you guys remember a trick I showed you? How do we switch a subtraction? You can multiply by -1. And don't we want a negative to show up? Remember, our answer has a negative in it. So we want that. So if I multiply this by -1, it switches the subtraction. So cosine squared minus 1 is actually equal to negative sine squared. So let's take this out. So that's 18 cosine beta over negative sine squared. Now remember what we're shooting for here. We need a negative and an 18. We found a negative and an 18. We need a cosine on top. We need 2 sines on the bottom. Don't we have all that? It's not written like this, so let's just split it up so it's written like that. But we've got everything. We have the negative of the 18, cosine on top, 2 sines on the bottom. We found it. Okay. So let's write the negative 18. Let's write 1 over the sine. Let's write cosine over the sine. Now let's look at how every piece is there. The negative in the 18. The cosine on top. 2 sines on the bottom. So it is exactly what we had. We're just taking the minute to kind of rewrite it to match what we were thinking the answer should have in it. And now we got the answer. So let's write it down. The answer is negative 18. That's a cosecant. That's a cotangent. It matches. We're good. Okay. So there is 25G. I know there's one that has some fractions. Just get yourself a common denominator. Show me as much work as you can. I will give you partial credit for that. But you got to show me something. Show me something to work with, okay? Okay, so after 25, the next problem that I circled was 26. So if you could please write down or pull up 26. Now 26 are equations. So we are looking for what angle measures solve the equation. So let's start with 26A. It's just an equation. Get the thing containing the x by itself. So let's subtract a square root of 3 to the other side. And then we have to ask ourselves, well, where is that going to happen on the unit circle? Well, on the unit circle, remember tangent is sine over cosine. So we really want the sine to be square root of 3 over 2 and the cosine to be 1/2. Now I put the negative up with the sine, But just one of them has to be negative and one of them has to be positive. So let's think on the unit circle. Let's see, where would that be? So the sign, let's see, right here, 2 pi over 3. So if you don't have your unit circle memorized in your brain, make sure you write it down. Now, 2 pi over 3, that point is 1/2, negative 1/2, positive square root of 3 over 2. So that's one of them. And then another one right down here. That is 5 pi over 3. It is also 1/2 square root of 3 over 2, but this time the x is positive and the y is. So the answer to A is 2 pi over 3 or 5 pi over 3. Now I left a little bit of room because do you guys remember if it says to solve it and use n, that's you just want to add 2n pi. So you just add 2n pi. The main thing is, can you find that 2 pi over 3 and 5 pi over 3? And you just automatically write down plus 2n pi. So that is 26A. Okay, now let's look at 26B. So now 26B. It's just an equation. Did you guys need to see that some more? Okay. So for 26B, get the cosine by itself. So let's subtract 5 cosines from both sides. So we have 3 equals negative 6 cosine. Divide off the negative 6. We're ready to go. Negative 3, 6 is the same as negative 1/2. Now, once you have it solved for the trig function, then you say, where on the unit circle does this happen? Where would the cosine be negative 1/2? Well, the cosine is negative in those two quadrants, so 2 and 3. The cosine is 1/2 at 2 pi over 3 and 4 pi over 3. And so the answer is 2 pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi. So that is 26B. Now, I didn't realize that 26D was a double angle one, so I'm going to cross that one out, and instead, let's do C. Let's do C. So we're going to do 26C now. So 26C says 64 cosine squared of x minus 16 equals 0. It made a circle. Okay, get the cosine by itself. Add 16 to both sides. Divide by 64. Now, 16 goes into 64 4 times. So we get the cosine squared of x equals 1/4. Okay. Now, what do we do to get rid of the square? What gets rid of the square? Square root, right? Now, what do you have to put in front of a square root, though? Don't forget that, because that's going to give you more answers. If you forget it, you're going to miss out on some answers. So we're looking at where the cosine of x is plus or minus the square root of 1/4. Now, 1/4 has a perfect square root. Just square root the top, square root the bottom. So the answer is, where is the cosine plus or minus a half? Where is the cosine plus or minus a half? So now, again, as soon as you get to that point, you're not done. Go to the unit circle and say, well, where does that happen? We keep getting the pi over 3s. I'm sorry, but anyway, the cosine is plus or minus 1/2 at all the pi over 3s. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So those are our answers. Put the plus 2 and pi. So our answer would be 2 pi over 3 plus 2 and pi. Oh, I'm sorry, I skipped the first one. Pi over 3 plus 2 and pi, in any order. 4 pi over 3 plus 2 and pi. And finally, 5 pi over 3 plus 2 and pi. Now, if it doesn't say 2 and pi, if it gives you on the interval from, say, 0 to 2 pi, your answers would just be 2 pi over 3, pi over 3, 4 pi over 3, 5 pi over 3. But if they mention that for any angle, you got to add that plus 2 and pi on to make it work. So that is some of your trig equations. Okay, so there's 26. Now the next problem that I had circled was 28. So if you want to look at 28, we're going to do both of those pieces. 28 says to find the exact value of that expression. If you look up on the board when you're taking your test, if you saw one like this, some of the formulas on the board are going to be your helpers. You might notice that the sine sum formula, let me write it down for you. The sine of x plus y is sine of x cosine of y plus cosine of x sine of y. You see how that follows that exact pattern? You're looking for the pattern. Look at the pattern. It goes sine, cosine, cosine, sine, sine, cosine, cosine, sine. There's a plus between them. There's a plus between them. That's how we know it's the sine sum formula. So A, we're just going to put that back together. So this is the sine of x plus y. Well, what's my x? Pi over 20. What's my y? Pi over 5. Now, usually the way it looks right now, it doesn't look like anything that we would know from the unit circle. But it actually is from the unit circle. Now, let me tell you why. You can either at this time make it degrees. Remember, pi is 180, so you can do it degrees and then look at that way. Or you can get common denominators. Most of you guys don't like fractions so much, so let's make it degrees. If you do 180 divided by 20, 180 divided by 20 is 9. So this is 9. And then 180 divided by 5 is 36. 9 plus 36 is 45. Oh, we found it. It is something on the unit circle. So now just ask yourself, well, what the heck would that be on the unit circle? Well, the sine of 45 is the y value at 45 squared 2 over 2. So it looks complicated. You're undoing and backtracking the formula, and it should end up being something that's on the unit circle at that point. Now let's look at B. If you look again up on the board, you're looking for the formula that goes cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Well, if we look on the formula, that is the cosine formula. And the one that has the plus on the right side and actually has a minus on the left. So the cosine of x minus y is the cosine of x, cosine of y, plus the sine of x, sine of y. So it kind of tricks you a little bit. The cosine, the sign in the formula is the opposite of what you start with. So this is really the cosine of 120 minus 30, because we're going to be subtracting those. So if it's a plus here in the cosine formula, it's got to be a minus when you put it back together. And you'll see on the board there the signs show up in blue. So just do that subtraction. 120 minus 30 is 90. This is the cosine of 90. Think about the point on the unit circle up at 90. That's the point 0, 1. So the cosine is 0. So those aren't so horrible. You know, they're pretty straightforward. Any questions about 28? So if you see something following those patterns, look on the board. Use that formula, undo it, you'll be fine. Okay, so there's 28. Let's look at 31 was the next thing. That also is a formula up on the board. We're going to use the double angle formula as you see, because we want the sine and the cosine of 2u. Now, what I suggest doing, you see this piece of information here? Draw a little xy axis. This is 3 pi over 2 and 2 pi. So build your triangle in that quadrant. Okay. So that's what they've told us initially. Now, if you think about sine being -4/5, if we build a triangle, well, actually, this is a u. Let's make that. If we build a triangle like that, we can make this the opposite and this the hypotenuse. I know the negative is with the sign because the hypotenuse is always positive. Remember that, always positive. So this is 5 and this is -4. Now, how can we find this? We need to also find that x. How do we find that missing side? If you know two sides of a right triangle, what can you use to find the third? We can use Pythagorean theorem, exactly. So I know that x squared plus -4 squared has to equal 5 squared. 25 is squared is 25. 16 is 4 squared. If you subtract them, you get 9. So x is either positive or -3. Well, which one is it? Well, if it's in this quadrant, isn't the x a positive because it's going to the right? So we know that that's positive. Okay, so fill in your triangle. Just a very basic, simple SOHCAHTOA sort of thing. Fill in your triangle so that we can use the formulas you see up there. So what do we know? We know the sine is -4/5. We know the cosine is 3/5. And if we needed the tangent for some reason, we'd just do opposite over adjacent. Okay. So now let's apply the formula. So if you look over here to the left, the sine of 2 theta is 2 sine theta cosine theta. So sine of 2u is just going to be 2 times the sine of u times the cosine of u. So we're just plopping that information we saw from the drawing, just plop it right into the formula. Just, make that as pretty as you can. 2 times 4 is 8. 8 times 3 is 24. So that's -24 over 25. Now, they also wanted us to find the cosine of 2u. The formula, so do you see how the third formula, 1 minus 2 sine squared, they gave us sine to start with. Why not just use that formula, and then if we screwed up the cosine, it won't hurt it because they gave us the sine. So you can use any of those. They'll get the same numbers, but I always use the one that less chance that I'm going to make a stupid mistake. So this is going to be 1 minus 2 times -4/5 squared. Because they told us the sine, just plop it into the formula. To square a fraction, square the top, square the bottom. The bottom of this fraction is going to have to be 25. 1 whole is 25 25ths minus 32 25ths is negative 7 25ths. So there is the sine of 2u and the cosine of 2u. If you wanted the tangents, just divide them, you'll have the tangent. They didn't ask for tangent. The next one I had circled was 34, the law of sines. Now, I'm only going to do 34a just for time. I want you to finish 34b and c on your own. Remember, at the bottom of this packet, if you scroll down, all the answers are right there. So anyway, whatever. So let's just start out. Let's do 34a. You can do b and c hopefully by yourself. Okay. Remember the law of sines. It is that sine of a over a equals sine of b over b equals sine of c over c. That might be something you want to add to your note card. And when it says to solve the triangle, remember, you're just solving for any missing pieces that you have. Any missing pieces. Now, if it was a right triangle, you could use SOHCAHTOA. You could use Pythagorean. This isn't a right triangle, so we can use the law of sines, and that's about it. Okay. So, we're missing angle A, but if you have two, it's a really simple process. Just use the 180 rule. So the sine of A is, let's just write angle A is. Angle A is just going to be 180 minus 104 and 45. And that's going to be 31 degrees. Okay. So now all the angles are accounted for. Let's look for the side A that's missing, because we've got a missing side. So I know that the sine of B over B is a full pair. I knew both the side and the angle. So it can help me find one piece of a missing pair, okay? Because remember, this is now we know is 31 degrees. So I know that's equal to the sine of 31 over little a. Now it's just a proportion to solve. We're going to cross multiply the two that are across from each other, divide by the one you haven't used, you got it. So in your calculator, you're just going to put the sine of 31 times 17 divided by the sine of 45. And you're going to get, let me do it again. The sine of 31 times 17 divided by the sine of 45. And you get something that's weird. Let's see. Oh, because I had it in radians. I'm like, that should not be that. Okay, just a second. Let me do it again. For the third time. Okay. Okay, so you get 12.38. Okay. Now we can do it one more time. Use that same pair you know. So sine of 45 over 17 to find the information about C. So that would be the sine of 104. Let me make that look easier there. The sine of 104 over C, because that's what's across from C. Same deal as far as setup. Make sure your calculator is in degrees. So you're going to do the sine of 104 times 17 divided by the sine of 45. And we get 23.33. Now it's not a bad idea to kind of look. The largest angle, 104, is across from the largest side, 23. Smallest angle is across from the smallest side. Medium angles across from the medium side. So that's just a really nice little quick check If that follows the case, you're probably okay. Okay, and then please finish B and C on your own. Any questions about law of sines? Okay, I want to do a law of cosines with you because that's on the test as well. So the law of cosines 1, I will do with you A, 36A, and again, you need to finish B and C. Let's do 36A. Okay, so let me tell you what the law of cosines says. So there are 3 versions, but you really only need kind of one, but if you want to write these down, we're going to go A squared equals B squared plus C squared minus 2BC cosine of angle A. Now, this is the key to make this work. These two go together. So if you start out with A squared, you're going to end with cosine of A. If you start out with B squared, you're going to end out with cosine of B. These two matches what is sitting next to the negative 2. So like if you wanted to start out with C squared, then you would have A squared plus B squared minus 2AB cosine of C. Do you see how these two go together? And these two match up with what's by the negative 2. So it really doesn't matter how you rearrange it. As long as you follow those rules, your rearrange it should be fine. Does that kind of make sense how you do that? Okay. So I'm going to start out, I'm going to use this one because I need to find A. So I have A information, so let's do that. And so if I start out with A, I know A squared is B squared plus C squared minus 2 times B times C times the cosine of angle A. Okay. Now what's really nice is this follows order of operations very well. If you enter it into a calculator, just that big string, it's going to give you exactly what you need, okay? And so we find that A squared equals, so 19 squared plus 38 squared minus 2 times 19 times 38 times the cosine of 30. Again, make sure your calculator is in degrees. That's 554.46. And so if you square root it, you get 23.55. Okay, so now that's A. To solve a triangle, you have to find all the information. Okay, so let's now go to angle, let's do C, what the heck. The only time angle C is going to appear is if we start out with C, so I have to use that version. So I know that 38 squared equals, now A squared I just found was 23.55. B squared is 19. 2 times A times B times the cosine of angle C. Now most people will write this part down correct, but then when it comes to actually doing it, you mess up some order of operations. So let me kind of show you some hints to enter into a calculator so you don't do that. What I want to do is I want to get an answer for these 4 pieces and leave them separate. So just enter them separately into your calculator. Okay, so 38 squared, 1444. 23.55 squared, 554.60. 19 squared, 361. Now, I'm physically going to do this. 2 times 23.55 times 19. And I get 894.9. Now, here's the part that people mess up. Algebraically, those things are stuck together. So we can't do a darn thing about it. These things we got to move to the other side by subtracting them off. Okay? So, if you take 1444 minus 554.60 minus 361, I get 528.4 equals negative 894.9 cosine of C. Okay. Now, how can we get that negative 894.9 off of the cosine? If it's attached to it like that, what math is going to get it off of there? Divide it off. Okay. So 528.4 divided by negative 894.9 is negative 0.590457. I'm just going to write lots of stuff. Because I'm not even going to enter that, take it out of the calculator. Now that's what the cosine of C is. So to find C, what do you have to push into your calculator to find a missing angle? You're going to have to hit the cosine, but you're going to make sure to hit the second button first, because that's going to take the anti-cosine or the inverse cosine. So the inverse cosine of that decimal is 126 degrees.
I think that's where I always mess up on these ones, is with the calculator.
Oh gosh, this one is the easiest to make a mistake because it's just this big run of all these things, and what do you do? And then just make sure, so what I always do, I get them separate, I take these ones off, then I divide. And if I follow that pattern every time, I don't usually make a mistake on the calculator. Okay, so now we found angle C. So look at what we found. We found A is gone, big C is gone. What's the last thing for us to find? Just angle B, right? And that's easy, right? We can use the 180 rule. So angle B is going to be 180 minus 126 minus 30, which is 24 degrees. Okay? So please finish those ones. And, it's not a bad idea to look over your, some of just the simple vector stuff, like magnitude of vector. But other than that, those are the main things that are on there. So I would definitely look over what we just did and what we did earlier in the week. Make up a note card with, some of the hints to yourself, or, whatever you want to put on there is fine. Okay?